This question is called Birthday Line, and it says, at a movie theater, a whimsical manager announces that she will give a free ticket to the first person in line whose birthday is the same as someone who has already bought a ticket. You are given the opportunity to choose any position in line. Assuming that you don't know anyone else's birthday and all birthdays are distributed randomly throughout the year, assuming 365 days in a year, what position in line gives you the largest chance of getting the free ticket? So when it says what gives the largest chance, we know we're going to be optimizing. We're going to find some equation in terms of a variable. And we're going to optimize such that that variable is maximized. Now, what can we do what variable can we use? The variable depends on how many people we have. All right, that's going to be our n. So this question is saying so if there's n people including us, that means the first n minus 1 people must all have unique birthdays. And then we're going to come along after them, and we're going to have a birthday that matches somebody in that n minus 1 people. So let's just draw that out. So there's these people, and this is all the n, and this is us, right? And this is the first n minus 1 people. So we're saying our goal is to have the same birthday as somebody in the n minus 1, but at the same time, everybody in n minus 1 should have unique birthdays. As you can see, that if you have more people, then the chance that you have a matching birthday with somebody will go up, but the chance that everybody having unique birthdays in the grouping will go down. Vice versa, if you have less people, the chance that you have the same birthday with somebody else goes down, but the chance that they have a same birthday amongst themselves goes down as well, so which helps you, right? You want to have them having unique birthdays. So the chance that they have unique birthdays goes up. Now, so we have to have two parts. So our P of, let's call it answer, P of answer, is the probability that first n minus 1 have unique birthdays times the probability that we share b-day with first n minus 1, and we're trying to have both occur at the same time, so we're intersecting them, so we're doing an AND operation. And we can do that for this case by multiplying because they're independent. The first n minus 1 having unique birthdays has no impact on whether or not our birthday matches theirs. And the same goes the other way. Independence is symmetric, so we can leave it at that. But we can also say that the first n minus 1, us having some birthday that matches will not impact their birthdays, and our birthdays will impact their birthdays. So it's just independent. There's no instead of saying we're gonna flip a coin and roll a dice, right? Those are independent outcomes, independent scenarios. Now, if we continue here, we can first tackle this portion. The chance that the first n minus 1 people have unique birthdays. Well, the first person can have any birthday. There's no birthday being blocked, right? So they can have any birthday. So 365 over 365. The next person so this is person 1, has 0 blockers. Person 2 has 1 birthday being blocked because the first person took a birthday, and that day is, if they match with them, then our scenario is broken. So person 2 can have 1 less available birthday. Person 3 has 2 birthdays blocked because now there's 2 birthdays that are not available. And so on and so forth until the n minus 1th person, which will have n minus 2 birthdays blocked. Now, if we continue on from here, that's going to be the first portion of our answer, so we can combine the terms a little bit. (365 to the power of n). And that's going to be times this portion, the chance that we share a birthday with somebody in the first n-1, assuming that they'll have unique birthdays, is the number of birthdays that they've taken up, so n-1 days, out of 365. This is n-1 right here. Okay, so it's n-1 birthdays have been taken up, and there's this many birthdays total available. 365 days in a year, n-1 of them have been taken up. We want to have a birthday that matches one of the n-1. So now that's going to be our formula, and we want to maximize this. How do we maximize this? Well, you can take a derivative, set it to 0, and see at what points of n does it stop increasing or decreasing. So at what point does it hit a peak and then stop increasing or decreasing? That has two issues. The first issue is that this is a discrete question. So you can't have differentiability assumes continuity, and this is a discrete question, which means that there can be one person, 2, 3, 5, 8. So there can't be 2.1, 3.3. That's the first issue. The second issue is derivative of this mess is going to take a long time. It's going to be pretty hard to do as well. So we can do is we can take a ratio of k people and compare it to k plus 1 people and see at what value of k do you stagnate and do you remain the same? Do you not increase so it's the same thing as taking a derivative, but this is like the discrete version of it, and also helps us because we can have terms cancel out via the division. So we're going to do like p of k plus 1 over p of k. I'm trying to see when they remain the same, so when that equals 1. You plug in k plus 1 into the top portion, you get 365 times 364, blah, 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 times 365 minus k minus 1 over 365 to the power of k, that's for k plus 1, times k over 365 over 365 times 364, so on, times 365 minus k minus 2 to the power of 365 to the power of k minus 1 times k minus 1 over 365. And all of these will cancel, including this term, but we leave that term alone. These will cancel, and almost all of the denominators will cancel, except we're going to have one 365 left over. So we get 365 minus k plus 1 to simplify a little bit over 365 times, and then this is left and this is left, so it's times k over k minus 1 is equal to 1. And then you just, you have 366 minus k over 365 times k over k minus 1 equals 1. 366 k minus k squared over 365 k minus 365 equals 1. And then 366k minus k squared equals 365k minus 365. And then, so it's subtract here. So it's negative k squared plus k plus 365 equals 0. And then it's k squared minus k plus 365 equals 0. And that's just like you can do quadratic formula, whatever. And the answer comes out to 20 people. That's the answer.